In this question, the position vector of a moving particle is given by vector r as a function of t is equal to minus the square root of t minus 4 in the I plus 4t in the j, for t going from 4 to 8 inclusive, where t is the time in seconds and r is the position from the origin in centimetres. Alright? What we've got to do is, in part A, we've got to find the Cartesian equation of the path travelled by the particle, and in part B we need to sketch the path of the particle on a Cartesian plane showing the direction of travel with an arrow. Alright, let's go for it, guys. In part A, first of all, we know that the x component of the position vector is minus the square root of t minus 4, that's this little beastie up here, and we know that the y component is 4t, that component there. Alright, now the game plan for us is to eliminate the parameter t. That's the third party in all this, so that we can then just get the straight connection between x and y, which is our Cartesian equation as required. So I think the simplest way for us to do that is to use this simpler equation here and express t in terms of y, and then put that t into here in terms of y, and then we have the connection we're trying to achieve without the t in there. Alright, so let's do that. If t is y over 4 from this equation, we substitute that into here, we get x is minus the square root of y over 4 minus 4, and if we re-express that a little bit, it's like that, minus the square root of 1/4 of y minus 16. Okay, now we've eliminated t, but we still need to hark back to t to find out where this particle started and where it finished on our Cartesian plane. So to that aim, we substitute first of all t is 4 into here for the x, and we get 0, and here for the y, and we get 16. So when it starts its journey at t is 4 seconds, we've got x is 0 and y is 16, the starting point for this segment of the journey where t goes from 4 to 8. Alright, now when t is 8 at the other end, we've got x is minus 2 and y is 32 by substituting in the same way to here and to here respectively. Now we're ready to get our Cartesian equation sorted out. We need to solve this thing for y, don't we? Okay, let's square both sides, and we get that. Simplify a little bit more, and we get that. Now if we add 16 to both sides, we get y is 4x squared plus 16, which is indeed our Cartesian equation. Voila! Now having done that, it becomes a very simple matter in part B then to sketch the path of the particle, because we've worked out it's a quadratic. 4x squared plus 16, and we know the starting point is here at x is 0, y is 16, and the finishing point is when x is minus 2 and y is 32. Okay, so let's do that. There it is. Okay, what we've got here is our y-intercept. That's the start of the journey when t is 4. That's the end of the journey when t is 8. So I've drawn the appropriate direction of travel, and I've drawn the end point in. I think everything's good, and I think we're good to go, aren't we? Terrific. So I think that's that question done and dusted. Hope you got some value out of that, and we'll look forward to seeing you soon.